Thank you. Thank you very much for the very kind introduction, Daniel. I like Daniel said, I get the privilege of going around and talking a little bit about Asterisk and sharing some of the work that other really great people do. I by no means I'm not the one that has implemented or written most of the things that I'm going to be talking about today, but it is a great privilege that I have to be able to work with those that do. And so I'm very excited to be able to discuss some of those things. I would like to start off to ask a question. How many of you have heard of Asterisk before? Okay, all right, this is good. Well, you know, the ecosystem is very mature. There are a lot of very good alternatives to using Asterisk, and I want to make sure that I'm not speaking to an audience that's not familiar with some of the things I'm discussing. Raise your hand if you have set up an Asterisk instance before. Okay, less hands, but still very many. All right, let me ask another question. How many of you actually utilize Asterisk in your business or your network or in, from capacity with customers, things like that? All right, still quite a few. One of the things that I enjoy about my job, or my new job, is I get to hear a lot about some of the awesome stories that people have in very unusual places that Asterisk gets used. And I think that having worked on Asterisk kind of from the inside for so long, I've sort of gotten tunnel vision, and I continually forget how many areas that Asterisk, and not just Asterisk, but open source telephony in general has impacted the world. You hear about the recent business state changes that have occurred to some of the old incumbents, like the Nortel, Alcatel. Some of the old giants of telecommunications are having to fight or change their business models. And I believe that it's largely because of the efforts of you and of many people that have been involved in moving the open source telephony revolution forward. So things that have costed lots and lots of money in the past now are free with the cost of some technical expertise and some self-learning and know-how. So I think that's really cool. So I'm going to introduce myself and talk a little about who I am. For those of you who don't know me, I've worked at Digium since about 2001 in various developmental capacities. I started out a very long time ago working with Mark Spencer, and he asked me if I wanted to get paid to work on open source software when I was about 18 years old. And I said, that sounds really cool. I was using Linux. And I thought Linux was really great, and I was really impressed with it. And I was learning to do some C software development and things like that, and that sort of just fit in my path going forward. Little did I know the impact of working on some of the open source projects that I worked with Mark on, and primarily Asterisk, what that impact would be. And so I am the benefactor of just some very convenient things that happen at the right place in the right time and with some very smart people. And so over the years, as I've worked at Digium, I've been able to work on Asterisk in different capacities, sometimes at a core role and sometimes in peripheral roles. I spent many years working and designing, helping to design and architect some of our hardware. So for any of you that many years ago may have used Digium ISDN interfaces, T1, E1 interfaces, analog interfaces to connect your first Asterisk instance or to the telephony network and to try it out and to kind of bring telephony home. I worked on the drivers over the years for those and also helped to design and architect them and learned a lot in that process. I also maintained libPRI, which is the ISDN stack for Asterisk for very many years and made many modifications and rewrote parts of it and things like that. And I am the Matt that Ole spoke of this morning that has a love for ISDN. There is a part of my heart that will always love ISDN, and I am not ashamed of that.
You're welcome to World City, man.
But I agree with him that it does not belong in SIP. In the course of working on hardware and working on ISDN stacks and things like that, I also saw that there was a need for, there was a vacancy for a free open source SS7 stack or C7 stack for Asterisk. And I decided that I was positioned from an education perspective to be able to maybe do some damage in that area. So I decided to write an SS7 stack for Asterisk, an open source SS7 stack. which is used all over the world in lots of different places. Believe it or not, SS7 is still used and is still alive, as much as even I like to think of it as being dead sometimes. Still a lot of people use it. After that, I was shanghaied away into different parts of Digium to build WebRTC related technologies and work on some initiatives related to the WebRTC movement. That was about 4 years ago or something like that, back when the browsers were starting to integrate it and the technology was very young and very changing. And you may think it's young now, but it was definitely a lot younger 4 years ago. And very recently, in the last year and a half or so, as Daniel mentioned, I was asked at Digium, after finishing that work, the WebRTC related work, they decided to move Matt Jordan into the CTO position so that he had more of an oversight role in the technology, in the role of technology within the company. They needed somebody to take his position as head of the Asterisk project, and they asked me to do that. And actually, for me, that was I was honored. I was a little bit overwhelmed, and I was really grateful for that opportunity. For me, it was in many ways the opportunity to come back home to something I've worked at in many different ways over the years, and then to come back and learn how to work with the different players and people involved at a different level. And I was really excited about that, and I still am. So that's my background. I'm going to talk a little bit about Asterisk and what's going on. And hopefully, my talk is going to be very technical today. I don't mean hopefully it will be technical, but it will be very technical today. And hopefully, I'm not going to be talking about things that many of you are not extremely unfamiliar with, but I'll try to take a step back and explain things that maybe are less familiar to people. Beginning of April, we had a new release of Asterisk 13.15.0 of 13 branch and the 14.14.0 release of 14 branch. And for those who aren't familiar, the 13 branch is our LTS branch, and so we have a longer, so the odd numbered releases of Asterisk typically have a longer support life cycle, so we fix bugs on those branches longer than we do on the even numbers. So 13 is the latest LTS that has been made. We also completed certification testing of the 13.13 certified release of Asterisk, and that's a hardened version of Asterisk that goes through certification testing within Digium. There's a QA group, and that's their job all day is to think of funny tests that they could do to try to break Asterisk. And those tests a lot of times are manual. They're not automated. They involve people. A lot of times it's a lot of creative thinking. And so the testing process takes a while, and it involves people doing certain things or whatever. And so that doesn't happen very often. It happens maybe once or twice a year. We go through that process. All patches, though, on the certification branch obviously go into open source Asterisk as well. So any bug fixes or anything that's discovered in that process gets propagated back into open source Asterisk. And the 13, for those who aren't familiar, the certified branch of Asterisk itself is open source as well. There was a contribution this last year by two gentlemen here who I believe live here in Berlin, Dennis Gousset and Frank Haas, to add binaural audio support to AppConfBridge, so you can do positional audio for speakers and things like that in the conferencing application for Asterisk, and that actually went in and went through the approval process and code review process and things like that, and it was merged. And there have been some jitter buffer improvements to better support FEC in Codec Opus. These are just a few things that have gone in recently, sort of line item type details. But if you are active in the project and watch the Garrett, garrett.asterisk.org, where our code reviews go through, on a daily basis, there are new contributions that come in. And if you look at the change logs between versions of Asterisk, it astounds me how much changes between each version and how many different contributions go in. And so I can't understate the scope of the amount of contributors and people who have an interest in development of Asterisk. And I'm continually humbled and grateful for everybody who are willing to go and take time to go through the code review contribution process, because it can be arduous sometimes. So moving forward, I want to start off and talk about what's going on with Asterisk in the master branch. And for those of you who aren't familiar with the way the branch schema works in Asterisk right now, the master branch is what is traditionally known as trunk, or the development branch of Asterisk, and what will become the new major release of Asterisk at some point. And presumably that's going to be sometime this year typically Astricon. So it would be probably a 15 at that point, depending on where we are with new features and the goals we have for 15. So how many of you seen these tricks on Facebook? Have friends that say, here are 10 bands. I've been to concerts for 9 of these. 9 of these are true that I've been to concerts to, and one of them is a lie. Do you have any friends that do that? It's kind of a new thing. All right. Okay, so I decided to play this game here. So I have 6 channel drivers. How many of you know what a channel driver is in Asterisk? Okay, good. Because after I read back over, I was like, oh man, I don't know how many people are going to even be familiar with some of these things. Okay, so some of you are familiar with channel drivers in Asterisk. So channel driver is a way for Asterisk to talk to a communications protocol, whether it be to SIP or MGCP or any number of other communications protocol. That's how Asterisk sees that protocol and abstracts it. So I have 6 different channel drivers listed here, and 3 of them utilize STP, and 3 of them do not. And I was wondering, does anybody want to try to take a guess at which ones are the ones? What's your name, sir?
Kenan.
Kenan, would you like to try?
SIP, PJSIP, and WebRTC.
Good guess. 2 for 3. All right, so I'll go through each one of those. That was a good guess. You had the ones that were very clearly. So Asterisk actually, so this is a trick question. Some of these aren't real. I made up some channel drivers for purposes of this talk. So this is not your fault. It was a trap. But ChanSIP, so ChanSIP is the original SIP channel driver for Asterisk. ChanJingle, it does use SDP. SIP as a protocol uses SDP to describe media sessions. And so just for raise of hands, how many people are familiar with SDP and what it is? Excellent. OK, good. I don't have to go into that. All right, so Jingle is Asterisk. Well, it was an old implementation of Google's Jingle protocol over XMPP. It does not technically use SDP to describe media sessions, but it uses a form of media session description that is fairly easily mappable to SDP as well. But that was not one of them. ChanPJ-SIP is the new Asterisk SIP channel driver. That's a more modern SIP channel driver and is built a little bit better. It's easier to extend, and it's easier to do things to without breaking everything else. ChanMGCP. So raise of hands, how many people know what MGCP is? Oh, yes. I love MGCP. I have a special place in my heart because the SS7 work, I did a lot of work with soft switch architecture and soft switch technology and things like that, and building big switches. How do you make an Asterisk look like a big SS7 switch, a box of Asterisk? And one of the ways I found out that the powers that be decided to do that was through soft switch architecture and with MGCP. So controlling media, separating your media plane away from Asterisk and controlling that on different boxes, and then using the soft switch as a controller of media plane, right? And so I did a lot of work with MGCP back when I was doing some of that work. And effectively you can make an Asterisk box look like a really big SS7 switch. ChanWebRTC is not real. I made that one up, and ChanSTP isn't real either. But they're useful things to talk about because if any of you are familiar with WebRTC, they decided in the implementation of WebRTC to implement it, and they're trying to figure out what they should use as a protocol. And they eventually decided not to use a protocol and just use SDP, offer answer, essentially, right? I mean, there's a little bit of state that's involved there, and Tim probably is shaking his head right now at my description here. But work with me, Tim. I'm just doing my best. Tim Panton over there. I've worked with him a little bit in the past with this. But after using the browser's view of how you set up media sessions and things like that with just using SDP session descriptions, I saw that eventually there could be a channel driver for Asterisk that is very simple and just uses SDP as a form of signaling. I thought that at some point would be very useful. So you may ask, why am I asking this question? So we decided that there are enough places in Asterisk that we need to be able to speak SDP, enough channel drivers, that it was time to abstract out an SDP layer, so to write a generic SDP layer for Asterisk, so that it could be used not just in current channel drivers, but actually in potential future channel drivers that could need to talk fancy new forms of SDP like are used in WebRTC. And for those of you that are familiar with SDP and WebRTC, it's not quite the same SDP that you're used to seeing in traditional SIP and in older protocols. There are some additional extensions and things like that that make it somewhat different. And so we decided that would be best done in a single place instead of being done multiple times in lots of different channel drivers. So for those that are interested, the abstracted SDP layer supports offer-answer state management. So it can do things like, in offer-answer, if the other end rejects an offer, like if you send an offer to the other side with an SDP in it, and the other side doesn't want to accept it, it can be rejected, and the abstracted SDP layer is going to handle things like rollback. So rollback of the session parameters to the previous version, so that it doesn't fail. Handle early, typical scenarios you find in most protocols, early media scenarios, like where you get an initial SDP from the other side, like in a 183, that are not final quite yet. So things like that. That may come into 200 OK later. And then the interesting thing is that, and I didn't make this choice, but the person that implemented made the choice to do it, but he abstracted the serialization side of it so that you could have a pluggable serialization layer. So that's where it actually serializes out to text. Which is interesting because you could potentially use it for things like Jingle, right? Like if it maps close enough to Jingle, you could use it to serialize out to Jingle and things like that, deserialize from it. That's hypothetical though right now, and so I don't want to go too far into that. So another interesting thing that's happening in Asterisk master branch is the Asterisk channel interface and core is gaining multi-stream support. So in Asterisk, Asterisk has been around for very many years, and for a very long time, it was very, very much outside the norm to have more than one audio and video stream associated with a call, right? That was typical, but then 3 or 4 years ago, the browser guys came along and just totally brought forward to the masses these really, really powerful clients that can do not just one audio video stream, but tons of video streams. And you can start doing some really cool things with them. A traditional conferencing experience before that time usually involved having a device called an MCU, which takes a bunch of video streams and it muxes all of them together into a single fixed size frame, and then it just sends it back out as a single video stream to the participants. But then, with the advent of browsers to be able to accept multiple streams at the same time, you have the opportunity to have these really powerful client-side video experiences like you see in Google Hangouts or in Jitsi Meet, where you have individual video streams. And you can do compositing on the client side, and you can move those video streams around and create really unique experiences on every client. And everybody can have their own perspective into what the conference looks like and what the communication looks like. So it really, really changed the world in terms of what you could build for end users. And so Asterisk has been working on a number of different things. There's been a new PJSIP channel driver that we've been hardening up, and we've been working on ARI and things like that. Also, WebRTC's technology has been changing quite a bit. And there was a time that we were staying on top of every single change, and it got to the point where it was changing so frequently, we decided to take a step back and update less frequently, and update as necessary some things. And so we slowed down some of our WebRTC development for a little while, and keeping up with the browsers. And so what we're doing this cycle is catching back up with that and trying to get a lot of the newer browser multi-stream support working. And so part of that was changing the core of Asterisk to be able to support multiple video streams and multiple audio streams. The goal was to do it there were a number of proposals on how we were going to do it. Some of them involved proposals that would involve breaking all the different channel drivers and applications in Asterisk, and I don't think anybody was thrilled about that idea. And so there was another proposal that was given to do it in such a way that maintains compatibility with all existing channel drivers for Asterisk and applications, but extends the channel API in Asterisk in such a way that newer channel drivers can write support for the new extensions. And so that's what was decided. And this is done through a new data structure called ASD stream topology. And a stream topology describes the state and the types of streams that are going to be talked to with a channel driver. Some of the cool things about some of the changes is that now if you're writing Asterisk applications, C applications at this time, you can, within your application, you can request renegotiation of the media parameters of a session with a channel driver. So for channel drivers that support it, like up and coming PJSIP and things like that, if that's talking to a browser that supports such things, you can go and change your video stream formats, parameters. You can change how many of them are being sent to or received from, and lots of really cool things like that. So just to kind of explain what a topology is, a topology kind of contains a bundle of streams, of AST stream objects, and each stream maps roughly 1-to-1 to an audio or video object, and so, or audio video stream. And so as part of the interface, an Asterisk channel can be requested. So at channel creation time, you can create it with certain topologies, and you can instantiate with it instead of having to renegotiate afterwards. And there's a new API at the bottom, AST channel request stream topology change, to explicitly request it from an application level. And so I decided to learn about some of the cool picture things. Like traditionally, I'm a text man, and then I was going over my slides, and I was getting really bored of it. And so I decided to play with pictures. And so one day I'll have slides as good as yours, Simon. But so I'm working my way up there. But this is essentially a representation topology and how it bundles up a number of streams together. And you can have different parameters associated with streams, different codecs, in different states like send, receive only, and inactive, and things like that. So another really important change that kind of just sort of hit everybody on the side of the head is, we found out this year that Chrome has decided that they don't care about supporting traditional endpoints that don't support RTP MUX anymore. I hope I said that right, because there's a lot of knots there. Let me ask a question. How many of y'all are familiar with RTP MUX? All right, that was probably more than I expected, actually, because as I was reading back over these slides, before this, I thought, man, nobody's going to know what I'm talking about. Well, what happened was, so RTP MUX is a WebRTC technology, and there's this game that WebRTC plays where they try to, so one of the goals of some of the WebRTC technologies is to figure out how you can set up connections, and they never, you can always set up a connection between browsers, regardless of like network topology, network hiding, and things like that. And so one of the things that they came up with was they decided that, so in traditional RTP land, RTP and RTCP reside on different ports. And they decided that the more ports, or they figured out, I won't say they decided because that's misrepresented, but they figured out that the more ports that you have involved in trying to connect two browsers together, and they're behind NAT or something like that, the more likely that that connection is going to end up failing. And so what they did is they came up with a way to multiplex RTP and RTCP over the same port, and the same UDP transport port, so that you can get rid of some of the number of transport ports that are required to be connected to have a successful call. In order to do that, there was some restrictions that they had to make on how you used RTP. They didn't do anything fancy like add another encapsulation layer to a framing header or some way to frame RTP and RTCP to say, okay, this is an RTP packet, this is an RTCP packet. They were very, they just kind of used, so it's very implicit, and it's based on heuristics of the data, like how the data is structured and things like that. And part of the restrictions that you have is that you can't use certain payload codes for RTP. So they put some restrictions on which ones you could use. So what they decided to do in Chrome 57 was deprecate support for endpoints that don't support RTP MUX by default. And there's some asterisks there because there's some magic flags you can pass into a peer connection to make it work. But the asterisks are there because if they want to sunset the support, and eventually it's going to be end of life. So we decided to get our act together and to get RTP MUX working in Asterisk properly, and we did that, and that was released in 13.15.0 and 14.0.4. So this is just a little bit of background with RTP and RTCP. So this is kind of what I said, that typically in traditional RTP and RTCP, you've got two ports, two UDP ports. One of them conveys your media data, and one of them, which is an RTP, and one of them conveys RTCP information, which is metadata about that RTP stream. So typically contains packet loss, round trip time, and other information. And this is what they did to change it, is they just dropped it all on top of one port, and they didn't really change a whole lot. They just put a bunch of rules about how you can't use it anymore. Some other things that are happening right now is obviously the changes that I discussed with regards to multi-stream support and STP API. They're abstractly done. So they're done within the core of Asterisk, but that doesn't necessarily mean they're implemented in a channel driver, which allows you to actually use them. So right now, in progress, we've got support to add, or we're in progress working on to add support to Champ PJSIP, which is the new channel driver, to support the new abstract STP layer, and also to support the new multi-stream APIs so that you can start prototyping and building fun new experiences like with JSIP and things like that in the browser. And also part of that, we're working on a new multi-stream echo application. So like I said, we've worked a lot on core components on this, but we've yet to have enough core components to do end-to-end tests. So we're eagerly getting to the point where we're going to be able to do an integrated test with the browser. And part of that is going to be a simple echo application in Asterisk that's going to take a stream from a browser, and then it's going to feed it back out, n number of other streams back to the browser and things like that. And then once we hit that point, that'll confirm a lot of things that we've been working on, making sure that some of our assumptions were correct. And like it says at the bottom, this seems really stupid and simple, but there are so many different pieces of technology that had to be developed to get this far that this is sort of the pinnacle of that work. And so you're thinking, oh yeah, la-di-da, there's a multi-stream echo application, who cares, right? That's what I said too, right? So here's a picture of it too. I drew a picture, right? I was in picture mood, so I decided to do a lot of pictures. Here's the echo application again. Get a stream, and then forward it back for other ways. But you prove a lot, right? You prove that you've got your STP negotiation working against a browser, which is a lot. You've proven that you've got the core of Asterisk, all the different streams separated properly and things like that. So there's a lot of technology there that just getting that one simple prototype application working. And not only that, but it is a very, very much a proof of concept for what I want to talk about next in terms of the stream topology and the way that the streams are set up for what you typically see in a typical SFU experience, like with Jitsi Meet or with Google Hangouts and things like that. And that's actually what we're working on in parallel as well, is extending the ConfBridge application in Asterisk to be able to provide an implicit SFU type experience, so that you've got, if you've got 4 participants or 5 participants, you're sending one stream out as a participant, and then you're receiving the other 4 participant streams back. So you'll be able to provide a star topology instead of mesh type topology that you currently have to do without any sort of SFU in the middle. Is everybody familiar with what an SFU is? Or familiar enough? A couple of people are. Yeah. So SFU is the video forward, is where you forward video streams instead of muxing it all, sticking it all into the same video stream. And this is a little picture of it, because I was in the mood to build pictures and things like that, showing browser A sending his video, and he's getting browser B and C's video back, and likewise for browser B and C, they have a similar experience, and those clients can build their own perspective of that conference, right? So you may ask, what's next after that, right? So there's more steps along the path to fully support the WebRTC media stack. We're taking a gamble right now that we're not going to need bundle support because we're trying to do this as quickly as possible. We're going to see how that gamble goes. We may have to do a last-minute bundle implementation as part of making things work in integration testing. And for those of you who are not familiar, bundle is an additional fun layer that they added in WebRTC to multiplex lots and lots of video streams and audio streams and their associated RTCP over the same socket as well. So yay for more optimization, right? ARI supports for the multi-channel video, and then ARI hooks for app ConfBridge, so that you can, as a developer on top of Asterisk, you can control the experience and do really cool things with it. Oh man, I ordered this slide wrong. Man, here's my punchline, guys. So I was going to play a joke on Ole and say, all right, well, the joke's on me this time. So, ISDN guy, love the ISDN. So my joke was less SIP, more ISDN, more SS7. But in reality, obviously, the past is in the past. So buy ISDN. And other things are better handling flexible multimedia applications in the next 1 to 2 years, improved Internet of Things integration, so RTMP channel driver would be kind of nice, and continuing to enhance out the audio and video support within Asterisk core. Just as a reminder, for those of you that use Asterisk 11 still, it went into security fix only mode in October. This means that it doesn't receive bug fixes anymore. Asterisk 11 is getting closer and closer to being dead on the vine. And it only receives, so if there's security vulnerabilities, it receives security vulnerability updates, and that's it. In 6 months, October 24th, it will be end of life, and it won't even receive security fixes anymore. So it's a good time to start moving forward to a newer version of Asterisk 13, maybe 14, if you're up for that. And that's it. Thank you guys very much for your attention, and let me talk a little bit about Asterisk at a Kamailio conference. In truth, I was very grateful for the opportunity to do so, because I figured a lot of people here either use it or have used it, and it's a very friendly and very technical audience. And so I can talk about some really cool things and have people actually understand what I'm saying, which sometimes it doesn't work out that well. So thank you very much.
Thank you, Matt. And thank you for all your work, 2001, yeah, young time. Probably many of us are here because of your early work. So now, questions. We have Saul.
Hey, Matt, great presentation. Thanks a lot for sharing.
No problem.
I have a question. I'm kind of relaying for Philip here on Twitter. Do you have any sort of preliminary plans, pun intended, on what the plan would be for the multi-stream SDP, unified versus Plan B?
OK, so that's a great question, actually. If I had like cookies or whatever, I'd throw you one right now. So maybe I should start bringing those. Yeah. David, do we have cookies of some sort?
No.
No?
Not English chocolates.
OK. So we talked about it, and although Chrome is great and it's been kind of the forefront for pushing things forward, they historically have utilized Plan B. We're going to shoot for a unified plan first approach, since it is technically the accepted way of going forward. There are a number of SDP translators that are available that we're putting a lot of faith and trust in that they'll be able to help back support existing clients and things like that. But we figured, since we're coming along at this point in the game, that we're going to go unified first. So, and then rely on translators if people need them.
Question back. Dan?
Hi, Matt. One for the audience. So if I'm running Asterisk 11 and I'm using WebRTC and I'm using this special flag, when do we expect Chrome to remove this special flag that then breaks WebRTC?
Dan, that's a great cookie question to you. I couldn't have paid you to ask a better question. Actually, it's a really good. So Dan actually was the one that sort of put the right people together that this was going to affect, at least from Asterisk perspective. And so he got me talking with some of the Chrome devs and trying to figure out a schedule for how this worked out. And I think right now, and Dan, you can correct me if I'm wrong, but if I remember right, we left off on about 6 months or so. So approximately about the time.
Day after 11 dies.
Exactly. So if you are using WebRTC with Asterisk 11, your WebRTC potentially will die the day after 11 dies as well. So it's really important to get moving forward to at least 13. Thanks very much, Dan. And that's not because of our choices. That's just because the Chrome team decided that was when they wanted to do final deprecation on supportive non-RTCP MUX endpoints.
OK, Matt. Thank you. Thank you.
Thank you.